Simplifying. When we talk about simplifying, how would you describe that? How do you interpret the word simplify? I think if I was to define it in the most basic way possible, I would say simplifying is organizing information. Okay, we got to organize information so that it's in a more condensed and simplified expression. Okay, now simplifying has a couple of facets to it. In this video, all we're going to be talking about is grouping. Okay, so I kind of broke it down a little bit here. So simplifying, like I said, has a couple of things that we have to understand. Some problems will have simplifying, but there'll be multiplication and division that we have to do. And then there'll be addition and subtraction. And it does kind of go in this order, in this descending order. But for us, we're going to start from the bottom. We're going to start with grouping, which is addition and subtraction. Okay? Now, just so you know, like I said, this video is only going to be about the addition and subtraction aspect of simplifying. So look ahead for the multiplying and dividing. Okay? And that would be distributive property, FOIL, the FOIL method. And we have to talk a little bit about how to multiply and divide exponents. So there's all these little things that to keep an eye out for in the future videos. Okay, so this is the first one about simplifying, grouping. Okay, so let's get started. All right. So the first example we're going to do is this one. Yes. 4 plus 7x minus 8y plus 9x minus 6. Can you see all that? Yeah, it's all there. Okay. So one thing I should have probably mentioned earlier, simplifying is, when we did simplifying when we were in elementary school, they would give us a problem like three apples, you have 3 apples, and then maybe you have 4 apples over here. How many apples do you have in all? So we would add them together, right? And then we would have 7 apples. But basically what we're trying to do here, or what I'm trying to let you guys know, is we started off with 2 terms, a 3 and a 4, and we simplified it to 1 term, 7. Okay? Now, again, grouping is always going to be an addition and subtraction. But it gets to the point where we're talking about grouping together terms that have variables, like the x here, for example, like the x and the y behind my head. So now how do we group those, right? Well, so we're simplifying terms that have variables. Remember that variables are letters that take the place of a number, an unknown number. And since we don't know that information, we're missing information. Sometimes we say, well, there's nothing I can do. And that's wrong. We can do some things. We can kind of simplify that stuff. So when I talk about grouping like terms, try to think of maybe, the way I like to think about it anyway, is grouping coins. You know, at the end of the day, usually I have some change in my pocket, and I take that change and I throw it in a bowl that I have at home. And when the bowl gets full, I have to simplify it. I have to organize it. So what I do is I dump it out on the table, right? And then I start piling up all the quarters, piling up all the nickels, piling up all the dimes, and separating the pennies. I'm grouping the like coins, the coins that are similar, if that makes sense, right? And then I put them in rolls and I count up my money. But that's kind of what we have to do here. It's kind of like I have a pile of pennies. I don't know how much it is, but I know they're all pennies. I have a pile of quarters. I don't know how much it is, but I know that they're all quarters, and I have a pile of them there. Okay? So that's kind of like the variable. You don't really know the total. You don't really know what that number is, but you know that they should all be together. They're all the same kind of coin. And so that's basically what we're going to be doing with like terms. So you might want to write that down. Like terms are terms that are similar in some way or another. Usually they have the same variable. That's usually how we would just describe a like term. So let's go ahead and start off with identifying some of the like terms. I'll start off with x. And the reason why I'll start off with x is because x comes before y in the alphabet. Okay, and that's usually the etiquette about how we express these terms when we have different variables. We usually just put them in x, y, z, or a, b, c. We go in that kind of order. Anyway, so let's start off with the terms that have x. So I have this one, and I have this one. I have two terms that have x. Now, remember, like I said before, grouping is always an addition or a subtraction. So I'm just going to be looking to the signs that each term has. The 7x is positive. The 9x is also positive. So a plus and a plus, you add them together, and they keep the same sign. So it's kind of like having 7 pennies over here, 9 pennies over here. How many pennies do you have in all, right? So I think that's 16. I'm adding correctly. 16 x's, okay? All right, so I basically simplified those two terms. So from 2 terms, we simplified to 1, just by adding them together. And if you want to put the sign, you can put the sign. It's not a bad idea to do that. So let's go to the next variable, the next term. I only have one y term. So there's nothing that this guy can't group together with the x because it's not the same. They're not like terms. This is an x, this is a y, they're not the same. And also, I can't group the minus 8 or minus 8y with minus 6, for example. They have the same sign, but the 6 doesn't have a y. So if it doesn't have a y, I can't put it together with the term that has a y. You can think about it like dimes, and that's a penny over there, and I can't put the dime with the penny, so I have one dime, right? I have one y, one term with the y. So I'll just bring it down. There's nothing to do with that one. All right? And the last terms that I have are these terms that don't have variables on them. They're just numbers by themselves. This is exactly like elementary school at this point. All we're going to be doing is, this is a positive. Remember, if a number or a term doesn't have a sign to its left, it's a positive, okay? Now I have plus 4 here, minus 6 here. If you remember the video about, adding and subtracting numbers with different signs we subtract, and the bigger sign, the bigger amount keeps the sign. So in other words, 4, 6 is bigger, so the answer is going to be negative because a 6 is negative, and the bigger number gets to keep the sign in the answer. Okay, so we subtract them. 6 minus 4 is 2, and since 6 is larger, it's going to be a negative 2. So essentially we simplified from 1, 2, 3, 4, 5 terms, we simplified it to 3 terms, okay? So again, always try to keep in mind that we're trying to group together coins, or trying to group together the things that are similar. And this is what's called like terms, okay? Let's do another one. Okay. Let's try minus 5x. Plus 16 minus 8x minus 14 plus 10x. Okay? Same thing. Maybe you might even want to pause the video and see if you can do it, right? And then I'll do it. So pause. Okay, ready? Here we go. So I'm going to look for the letters first. I've tried to always group together the terms that have letters, okay, or variables, we should say. And if I have more than one kind of variable, I tend to put the variables in the order of the alphabet, in alphabetical order. Okay? So here I have terms that have x. I have 3 terms that have x. Okay? Now I just got to pay attention to their signs to see if I add them or subtract them to see how many I have in all at the end. Okay? So let's just start with minus 5 and minus 8. That would be like owing $5 and owing $8. So in all, I owe $13. But now I have 10. That's a positive, so I subtract them because they're different signs. And the bigger sign, or the bigger number, keeps the sign, right? Okay, so I think that would be, let's do it again here. We have minus 5 minus 8, that's minus 13x. Plus 10x, it's going to leave me with minus 3x, okay? It's basically 13 minus 10. 13 is bigger, and 13 keeps the sign negative. Okay? Now, okay, I grouped together these 3 terms. So now I have 2 terms that don't have variables. They're just numbers, right? Numbers and their signs. So we can group those 2 together. Those are like terms that can be grouped. So, underline them too, why not? Plus 16 minus 14. 16 minus 14 is positive 2. And that's all you can do. We can't do anything more because we don't know what the variable is. We don't know what x is. And so I couldn't do anything with all of the x's in these ones, but I can put them together. I can pile them together. I can simplify them, right? Okay, let's do another one. All right, okay. Let's try 3x plus 2 minus 5x squared plus x squared minus 5, that's a squared here, minus 5 plus 9x. Does all that fit in the screen? Yes, it does. So again, maybe you want to pause the video and give it a shot, see what you can get. Okay, so pause. Okay, here we go. Something I should mention at this point, because something's different about this expression compared to the last two that we did. We have x here, we have terms that have x, and then we have terms that have x with an exponent, like x squared, for example, right? So, just so you know, x squared is not the same as x. These two terms, for example, are different terms. I can't group them together. But Raul, they have x's. Don't you just put all the x's together? Yeah, but no. If it has an exponent, I can only group together the terms that have the same letter, the same x, same variable, and the same exponent. If it doesn't have an exponent, I can't group it together with a term that has an exponent. So I need to keep them separate, just so you know. All right? And also I should mention that we put them in descending order, the exponents. So if you want to imagine the x that's by itself, it kind of has an exponent of 1, but they'll never put the 1. You'll never see a 1 as an exponent by an x, okay? So we'll put the x squareds first. So because it's a bigger exponent, that's all it is. Bigger exponent, smaller exponent, variable without an exponent, and then the numbers. That's kind of the etiquette of how to express these kinds of terms, okay? All right, so we have two terms that have x squared. These are like terms, okay? Because they have x squared, both of them do. And remember that x by itself, it's kind of like it has a, I don't know if I've said this before, but it's kind of like it has a 1. But they never put the 1 in algebra. In algebra, they never put the 1 x. They never put the number 1 before it. And you might ask, why? Well, if I take the 1 away, and I ask you, how many x squareds do you see here? 1. So why do I got to put the number if it's obvious that you can only see 1x, right? I don't know if that makes sense, but that's why they don't put the 1 in front of it. But you got to consider it like a 1. In this case, a positive 1, okay? So we have a minus 5x squared plus a 1x squared. And being that they're different signs, we subtract them. And the bigger one will keep the sign, negative. So it's going to be a minus 4x squared, okay? Let me put this over here. Okay, and that was just grouping together these two. Okay? All right. Hope that makes sense. So we simplified those two terms into one term. We condensed them. We organized them. Now I'm going to go to the x that doesn't have an exponent. Okay? Let's look at these guys. I have two terms that have x. They're like terms because it's just an x by itself. I mean, no x squared. Okay? So the 3, remember, if it doesn't have a sign to the front and to the left of it, it's a positive. So the 9 is a positive, the 3 is a positive, so we can just add them together and they keep the same sign. So 3 plus 9 is 12, positive 12x. Okay, so we simplified those two terms. And now I'm left with, I'm left with numbers that don't have variables. And so I can just put those guys together also. I can just group them together. Different signs, negative 5, positive 2, we subtract them, and the bigger number will keep the sign, so it's going to be a negative 3. 5 minus 2 is 3. And the bigger one is 5, so that one keeps the sign. Okay? And that's how it is. That's how we do that. So I'm going to go ahead and put 2 more, and I'll let you guys do them, all right? And then we'll do them together. Okay? So, all right. So I have them written down on my other board here. I think you can see that. I will read it to you. This one says negative 2x squared minus x plus 5x squared plus 10x minus 7. Okay? And the other one I want you guys to try and do is this one. 5x cubed minus 2x squared plus 7x cubed minus 5 minus 8x squared. Okay? So go ahead and take a minute, pause the video, and see if you can do them on your own, and then I'll do them, and then we'll see what we get at the end, okay? Oh, one thing, remember the exponents go in descending order. Descending order. So that means the biggest one first, the next one, next smallest one next, and you just keep going down until you don't have any exponents. Okay? All right, so go ahead and pause the video. Okay, so I'll go ahead and do it. Now, for the first one, I'm just going to go ahead and start off with, obviously, the exponent that's the largest. In this case, it's the squared. I have two terms that don't have exponents, right? So those will be next. And then I only have one number. I think that guy's going to end up being by himself, the -7. So I would hope that your answer finishes with a -7, okay? All right, so let's start off by grouping together the x squareds, these two like terms. This is a -2, this is a +5. The x squared just goes along for the ride, so I can put the x squared there. Really what I'm trying to do is add or subtract the numbers that are in front of the x squared. So, being that they're different signs, we subtract them and the bigger one will keep the sign. So 5 is larger than 2, 5 is positive. So that's going to be my sign. 5 minus 2 is 3. So I have positive 3x squared. And that's what I get after grouping those two terms together. Now, I have 10x, a positive 10x, and a minus x, or a minus 1x. Remember, they'll never put the 1 in front of there, so we have to get used to seeing that now and understand that it's a 1. So 10 minus 1 is 9, positive 9x. And now I group together those two terms. And like I said, the 7 doesn't have a buddy to group together with, so he's kind of by himself. Minus 7. That should be your answer for that one. 3x squared plus 9x minus 7. So how did it go with this one? Okay, we have terms with different exponents, right? So I said to start with the largest exponent first and begin grouping those ones together and then work your way down, okay? So we have these two. We have 5x cubed and 7x cubed. They're both positives. 5 doesn't have a sign, so that means that it's positive. So 5 plus 7 is 12. So we have 12x cubed, and that gets rid of those two. And what's the next exponent in the descending order? That's going to be the squared. So I have these two terms that I need to group together. Minus 2x squared minus 8x squared is minus 10x squared. Remember, same signs, we add them together and they keep the same sign. Okay, so those two are grouped. And the same thing happened here, and I didn't even realize I did that, but the 5 doesn't have a buddy either, so he just kind of comes down at the end of the whole expression. So that's it. Oops, you know what, I forgot something. Did you guys catch it? I forgot to put my squared on the 10x. Okay, it's 10x squared. Maybe, hopefully you caught that. Whew, that was a close one, I almost messed up there, huh? Okay, so again, this is grouping. Grouping together is always going to be an addition or a subtraction. And you're trying to group together the terms that are similar. And how do you tell if they're similar? Well, if they don't have an exponent, if they don't have a variable, they're just numbers, those are like terms. You can put them together depending on their signs. If they have variables, you got to make sure the variables have the same exponent. Either no exponent, put them together. If they both have x squared, for example, you put them together. So I think you get the idea. I'm being a little repetitive now, so I think I'll stop. So good luck. Again, look ahead to the multiplying and dividing of these kinds of terms.